All right, so now let's start talking about this third page of final review number 2. A statistician was exploring a set of data that showed the mean was 99 and the variance was 25. Find the standard deviation. Well, the standard deviation is always the square root of the variance. In this case, if the variance is 25, the square root of 25 is 5. So that's the standard deviation. In a board game, the table shows winnings and probabilities when spinning a pointer. What is the expected value of a spin? So the probability of getting $50 is 1/20th, and we know we multiply the amount you would win by the probability of it happening. So 50 times 1/20th is 2.5. Next up would be 100 times 3/5, which is 60. And then 150 times 1/10, which is 15. And 200 times a quarter, which is 50. Add those values up, you come up with 127.50. Okay, next up is, let me just check something here. Let me make sure. Yep, we are on 2. Okay, sorry for the delay there. I wanted to make sure we're on sheet 2. I wasn't sure that we were. This particular one looked a little familiar, but no, we're good. Okay, order the following z-scores from closest to the mean to furthest from the mean. Now, plus and minus don't mean anything. This is distance from, if you will, 0, which is like absolute value. So the smallest number would be negative 0.05, then would be 0.15, then would be negative 0.2, and then would be 1.05. Okay? All right. So again, absolute value is all that matters here. You just look as if every one of them was positive and order them from smallest to largest, with the smallest one being the closest to the mean. Number 13, suppose your statistics professor graded your test with a z-score. You earned a 4.2 on the test, woohoo, with a mean of 65 and a standard deviation of 8. I can imagine what your parents would say when you get a z-score of 4.2. I don't think your parents would be very happy. But when you convert and show them what you have learned in statistics class, standard deviation's 8, multiply it by 4.2 for the z-score, you get 33.6. 65 plus 33.6 is 98.6. You will be happy. Yes, and so will your parents. It works out great. Okay. The test scores for quantitative reasoning section of the GRE are normally distributed. The mean score is 150 with a standard deviation of 8.75. The test scores are blah, blah, blah. Find the z-score. We don't want each value. We only want to find the one for 168. So 168 minus 150 is 18. Divided by 8.75 is 2.06, which means it's a little more than 2 standard deviations above the mean. And that makes sense, right? Because each standard deviation is 8 3/4. Multiply it by 2, you get 17.5. And 18 is a little bigger than that. So it works. Number 14. Evaluate if x is 2, 7, 4, and 3. The sum of the squares of x plus 3. So 2 squared is 4, 7 49, 4 squared is 16, 3 makes 9. Add those all up, you get 73. So you're doing this, the sum of x squareds. In order to add the 3 first, it would have to be inside of a parenthesis. Since it's not, we only square the x's. That gives me 78, and then I add the 3. That gets me 81. Next one, subtract 5 from each of them. 1 minus 5 is negative 4, plus negative 3. 3 minus 5 is negative 2, add that. 4 minus 5 is negative 1, add that. 5 minus 5 is 0, add that. The whole thing is negative 10. Multiply that now. See, the parentheses said subtract the 5 first. Then negative 4 times the sum says get that sum, which we did. It's negative 10. Multiply it by negative 4, and you get 40. Okay. For some reason, numbers 16 through 20 are not answered. So I will come back and get those in a later video. Okay? So I'll get those in a later video. For number 21, change the mean to 48,000 and the standard deviation to 15,000. Annual salaries, blah, 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 cross out the 48, make it 15. Now, this is a really, really great question because it's all the possibilities with normal CDF function and the probabilities under a normal curve. In the first case, it's less than. In the second case, it's between two numbers. And in the third case, it's greater than or more than. So for the first one, less than. That means start with the smallest number you can, and in this calculator, we put in negative 10 to the 99th, as recommended by the text. The maximum value you can get is 40,000 because you want to be that or less. 48,000 is the mean, and 15,000 is the standard deviation. Comes out to be 30%. Next one's between 45 and 60,000. So minimum is, or the lower is 45,000. The maximum is 65,000. The mean is 48,000. Standard deviation is 15,000. Again, everything in this is second VAR's normal CDF. I'll tell you 45%. And next up, what percent of the people earn more than 70,000? Well, that's from 70,000 as the low to as high as it gets, which is positive 10 to the 99. 48,000 again, mean, standard deviation. You'll notice the means and the standard deviation stay the same on every problem. It's just where you're going from and to that changes. When you crunch those numbers, you come up with 7%. Okay? The population mean average annual salary for plumbers is $49.10, random sample of 36 plumbers. Mean salary, so you're looking here at central limit theorem. So it is, again, second VAR's normal CDF, and you do everything you just did. You want to see greater than 47,850, so 47,850 is the low end to the maximum of 10 to the 99th. The mean is 49.1, but when you do the central limit theorem, you have to remember to divide by the square root of how many there are. In this case, it's 36 plumbers. So you take the square root of that underneath the standard deviation. Crunch those numbers, you get 0.9137. Okay? Very quickly, the last one is population. It's a definition thing. And number 23, you're going to put in now the list for Toyota. Put that all in. And you're going to go to Stat Edit. You put the list in L1. Then you go to Stat Tests, and you go to Choice 8, the T interval, because there's so few scores, it's a T test. Input from the data. The list is L1. The frequency is 1. And the confidence level you're looking for is 0.95. When you crunch those numbers, it'll show you 29.697 to 33.992. Make sure you use a T test, not a Z test, because there's so few scores.